Alright, question 4. John, Paul, and Kim are making a rectangular pizza that they will slice into equally sized rectangular pieces. John Paul only likes pieces that have the crust attached, which are the outside edge pieces, and Kim only likes pieces that do not have the crust attached, which are the inner pieces. They both want to eat the same number of pieces. How many slices will there be if they cut it so that there's an equal number of pieces for both of them? So I drew up an example here, but as you can see, the edge pieces, there are 18 of them, and there are only 12 inner pieces. Okay, so they'll be disappointed because they want to have the same number of pieces each. So how can we build it? Maybe we can cut it in different ways so that there are going to be the same number of inner pieces than outer pieces. So let's build another pizza with it just doesn't really matter how many slices we have. For now, we're just going to use variables here. So we can call this length right here, call that x. So it's going to be short of the side of this pizza. I just find it's going to be easier because the inside number of pieces is just going to be x times y. So we're going to call this x and we're going to call that y. So now we could easily build a couple equations. We can say that x times y is equal to the number of inner pieces, and the number of outer pieces is equal to 2x plus 2y plus 4. Alright, so we just have to make sure that n1 equals n2, or sorry, ni equals no, n inner and is equal to n outer. Okay, so xy has to equal 2x plus 2y plus 4. And now we just rearrange this, get all the y to the left and get all the ones that don't have y to the right. And now we could factor out the letter y because that's a common factor on the left. Now we could divide both sides by x minus 2 as long as x doesn't equal 2. So now we have a rational equation. Y equals 2 times x plus 2 divided by x minus 2, comma, x can't equal 2, of course. Alright, we can graph this. There will be a horizontal asymptote at y equals 2 because we have linear on the top and a linear on the bottom, and the a values are 2 over 1. We're going to have a vertical asymptote at x equals 2 because x equals 2 would make the denominator equal 0. And we'll have a 0 at x equals negative 2 because the numerator is 0 when x is negative 2. Plug in x equals 0 to see where the y-intercept is and graph away. Alright, so this graph is these are all solutions to our problem. But the problem we have now is that you can't have 1.3, like x can't be 1.3 or 1.4. These are all natural numbers, right? So you can't have any decimals, you can't have any negative numbers, you can't have negative cuts across, right? So we have to look for only natural numbers that satisfy this equation. Both the x value and the y value have to be natural numbers. So that means we can eliminate anything that has negative x, and we can eliminate anything that has negative y. Right? So we're only looking at our solutions in this area right here. But also, we can't include anything that's a decimal. So we really have to kind of go through all of this and see how many answers all the way off to infinity are there where both x and y are going to be decimals. So let's just kind of do it orderly, in order, like little at a time. At 2, obviously nothing can happen, like there's an asymptote, so there is no value that satisfies this equation. Let's try, let's do a table of values. Let's try x is 3. So when you plug in a 3, you get 2 times 5 divided by 1, so that it's 10. Looks like we already have ourselves a solution. All right, let's try 4. So with 4, you get 2 times 6, so 12 divided by 2, 6. That's another solution. At 5, you get 14 over 3. Okay, that's not a solution because you can't have 14 over 3 slices. What about x is 6? Well, here you get 16 divided by 4. You get another valid answer. You get 4. Now let's try 7. X is 7. You're going to get 18 divided by 5. Not a valid answer. Can't have fractions here. Okay, moving along with x is 8. We will get 20 divided by 6, which is a no-go. That's a 3.3333. When x is 9, we get 22 divided by 7. That's no good. And when x is 10, we're going to get 24 divided by 8. Oh, that's another solution. 24 divided by 8 is 3. Now, as you can see this from the graph, the numbers are going down on the right. So after 10, after we got to 10 comma 3, you'll see the y value is always going to be less than 3, but it's always going to be greater than 2, but it'll never reach 2. So that means every y value from there, from x is equal to 10 all the way to infinity, will be between 2 and 3. It'll never be another whole number. All right, so we do have 1, 2, 3, 4 solutions. Right, so that means, let's check out what these 4 solutions mean. If x is 3 and y is 10, then that means the number of inner pieces will be 3 times 10, 30, and the number of outer pieces will be 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. And we'll have another 10 here and another 10 there for a total of 30, so it works. Now 10 and 3 down here will work in the same way. That's just the symmetry of it, right? So if you have 10 over here and 3 over here, that would be the same thing. And same with 4 and 6 and 6 and 4. That's just symmetry. So some people would say there are 2 different answers. Some people would say there are 4 different answers. But the final answer is John Paul and Kim should cut it so that there are 5 pieces one way and 10 pieces the other way, or so that there are 6 pieces one way and 8 pieces the other way. And we've proven that there are no more solutions, because as far as you can see off to the right, you will never get another natural number for your y value. And so there you have it.